Students, in this video we will study about some things related to straight lines, like to find the line perpendicular or parallel to a given line. Find the line parallel to a given line. If given line is ax plus by plus c is equal to 0, we have to find a line parallel to this line. So to find a line parallel to this given line, replace this constant c by another constant, that is the equation of a line parallel to this line is ax plus by plus lambda is equal to 0. This lambda is a scalar quantity and this is unknown to be obtained. Ax and by will remain same, there will be no change, and this constant will change only in case of finding a parallel line to a given line. And to find this unknown lambda, a condition in question will be given, like this line means the line parallel to given line is passing through origin or some other point. So if this line is passing through origin, then coordinates of origin v 0 0 will satisfy this equation, means x and y are replaced by 0 0. If this line passes through origin, then a into 0 plus b into 0 plus lambda is equal to 0. This provides lambda is equal to 0. And putting this value of lambda in this equation, so we get ax plus by is equal to 0. This is a line parallel to a given line. And if instead of origin some other point is given, then in same manner we will replace xy by that point and find value of lambda and replace this lambda by that value. Then we obtain this line. This line is parallel to this line. And now we will find a line perpendicular to a given line. Find the line perpendicular to a given line. If the equation of given line is ax plus by plus c is equal to 0, then the equation of line perpendicular to this line is ay minus bx plus lambda is equal to 0. This is a line perpendicular to this line. To find a perpendicular line to a given line, x is replaced by y and y is replaced by minus x, and constant is replaced by another constant lambda. Then we obtain this equation, and this equation represents a line perpendicular to this line. And in same manner, to find the value of lambda if this line passes through origin, then value of lambda will be 0 because x and y will be 0. And if line passes through another point, suppose 1 comma 2, if this line passing through a point 1 comma 2, then replace x by 1 and y by 2 in this equation to find the value of lambda. That is a into y की value 2 minus b, x is here 1 plus lambda equals to 0. Lambda equals to, and now value of lambda equals to b minus 2a, and replace this value of lambda in this equation. We get ay minus bx plus b minus 2a is equal to 0. This is the required equation of line perpendicular to this given line. Given line is this. In question, a and b will be given. A and b will be some numerical numbers. So unknowns will be only x and y. So this is a line perpendicular to a given line. Another thing related to straight lines means to find the coordinates of point of intersection of two lines. Find the coordinates of the point of intersection. Point of intersection of two lines. Whose equations are a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. These equations may be solved in some other manners which you have studied in class 10th, like elimination method, substitution method, or cross multiplication method. Any method can be used to find the values of x and y. Values of x and y together will provide the coordinates of point of intersection, or x upon b1 c2 b1 c2 minus b2 c1, value of y a2 c1 minus a1 c2 and 1 upon a1 b2 minus a2 b1. Then value of x b1 c2 minus b2 c1 upon a1 b2 minus a2 b1, and value of y equals to a2 c1 minus a1 c2 upon a1 b2 minus a2 b1. To find values of x and y, and these values of x and y will provide coordinates of point of intersection of two lines. And now the condition of concurrency. The condition of concurrency three lines if equations of three lines are a1x plus b1y plus c1 is equal to 0, comma a2x plus b2y plus c2 is equal to 0 and a3x plus b3y plus c3 is equal to 0. Congruency means three lines are passing through a point like this. These three lines are passing through a single point. So the condition that these three lines are passing through 3 points is the required condition is determinant a1 b1 c1 a2 b2 c2 a3 b3 c3 is equal to 0. If determinant value is 0, then we say that three lines are concurrent. Concurrent means they are passing through a single point. Expansion of this determinant can be expanded in this manner. Take a1 and leave this row and this column passing through this point and take cross multiplication of v2 c3 minus b3 c2 and then minus b1. Leave this row and this column passing through this point b1 and cross multiplication of a2 c3 minus a3 c2 plus c1. Leave this row and this column, first row and third column, and cross multiplication of a2 b3 minus a3 b2. If this product is 0, this expansion is 0, this shows that three lines are concurrent. Next, angle between two lines whose equations are a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 equals to 0. Find the slope of first line, and slope of first line by converting this line into y is equal to mx plus c. Y is equal to minus a1 upon b1 x minus c1 upon b1. So slope of this line m1 is equal to minus a1 upon b1. Slope of another line, convert this line into the form of y is equal to mx plus c. So y minus a2 b2 x minus c2 upon b2. So slope of this line m2 is equal to minus a2 upon b2. Now the angle. If angle between these two lines is theta, then tan theta equals to mod of m1 minus m2 upon 1 plus m1 m2. m1 slope of first line find in this way, M2 slope of second line, find in this way and substitute their values and find positive value. Mod means positive value of tan theta, and positive value of tan theta will provide acute angle. Acute angle means if two lines intersect, then we find one acute angle and other obtuse angle. If we have the value of acute angle as 30 degree, then obtuse angle will be 180 minus 30 by 50 degree. So both angles may be obtained. This will provide us acute angle because of this mod. Mod means positive value, and positive value gives you acute angle. If theta is equal to 90 degree, that is, lines are mutually perpendicular to each other, then m1 into m2 is equal to minus 1. This is the condition of perpendicularity of two lines. If two lines are perpendicular, then product of their slopes equals to minus 1. Number 2, if theta is equal to 0, theta equals to 0 means lines are parallel, then m1 is equal to m2. m1 is equal to 0 means slopes of two lines are equal, means they are parallel, and if product of slopes is minus 1, they are perpendicular. So angle between two lines and two conditions are here. And now position of 2 points relative to a line. Position of 2 points relative to a point, relative to a line, not point. Let equation of line is ax plus by plus c is equal to 0, and coordinates of 2 points are x1 by 1 and x2 by 2. If the quantities ax1 plus by1 plus c and ax2 plus by2 plus c have same sign, then points will lie on same side of the line, and otherwise they will lie in different sides. Means if the sign of these two quantities are different means this is positive and this is negative, or this is positive and this is negative, signs are different, then points will lie into different sides. Like line is this, one point is in this side and other point is in this side, so points are on two opposite sides. Or if the signs of these two quantities are same, then point will lie, both points will lie on same side, either this side or that side. So this is the position of 2 points related to a line. And now distance of a point from a line. Distance of a point from a line. From a line ax plus by plus c is equal to 0 equals to mod of ax1 plus by1 plus c upon root a square plus b square. X1 y1 are coordinates of point, and a b c, which quantities are used in this formula, are coefficients of x, y, and c is constant, the term independent of x and y. So this is the formula for finding distance of point from a straight line. If this point is origin, means coordinate of points are 0, 0, then distance from origin, coordinates of origin be 0, 0, distance from origin to line is equal to mod of c upon root a square plus b square. x1 y1 are 0, 0, so x1 y1 are 0, 0, so first two terms will vanish and rest c. So c upon root a square plus b square. Mod is used because distance always be positive. So if the sign of c is negative, then avoid that. Distance. And now in same topic, distance between two parallel lines. If two lines are parallel, distance between two parallel lines. Equation of lines are ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0. Distance between these parallel lines is equal to mod of c1 minus c2 upon root a square plus b square. In parallel lines, in same video we have studied that coefficient of x and y will remain same. So ax plus by and ax plus by will remain same and constant term will change. So constant term in first line is c1 and second line is c2. So So distance between two parallel lines is given by this formula, mod of C1 minus C2 upon root A square plus B square. And now one more thing, area of a parallelogram. Area of parallelogram. If equations of sides are known, equations of sides are known, this is parallelogram A, B, C, D, and equation, this AB line is A1x plus B1y plus C1 is equal to 0, and since this is a parallelogram, so AB and DC are equal and parallel, so equation of DC line will be A1x plus B1y plus D1 is equal to 0. In parallel lines, constant will change and coefficients of x and y remain same. So C1 instead of C1 here will be D1. If line equation of this line BC is A2x plus B2y plus C2 is equal to 0, then equation of parallel line AD, which is parallel to BC, is A2x plus B2y plus D2 बराबर 0. D2 is equal to 0. So equation of these four sides are these. Then area of parallelogram equals to C1 minus D1 into C2 minus D2 upon determinant A1 B1 A2 B2, and this will be in mod, or C1 minus D1 C2 minus D2 upon, इसे एक्सपेंड कर सकते हैं, this determinant can be expanded like this A1 B2 minus A2 B1. So this will provide area of parallelogram, and this video completed.